Let's talk about remainder theorem. So the remainder theorem states that when a polynomial p of x is divided by x minus a, the remainder is p of a. So for example, right, if you were to divide p of x, right, with like x minus 2, then p of 2 is the remainder. Okay. If you don't get that, then I'll go through an example and then it'll make a lot more sense. So here we're asked to find the remainder of this polynomial when it's divided by x minus 2. And it's really easy. All you need to do is find the remainder, which is going to be p of a. And in this case, we use p of 2. Okay? And p of 2 is just subbing in 2 into this polynomial. So 2 cubed minus 5, 2 squared minus 2 plus 4. Okay? And then this is equal to 8 minus 20 minus 2 plus 4, which then equals to minus 10. And so therefore, minus 10 is the remainder. Now let's say you're dividing with x plus 1. So in this case, right, you won't write p of 1, but you actually write negative 1 because the remainder theorem has a negative, okay, but this has a plus. So here you want to use p of minus 1. And then you just sub in minus 1 into the polynomial, so like that. And then just evaluate it, so minus 1, minus 5, plus 1, plus 4. And this should give you minus 1. And therefore, minus 1 is the remainder. Alright, so let's talk about the factor theorem. It essentially states that when a polynomial is divided by x minus a and the remainder is 0, then x minus a is a factor of px. In simpler terms, if you have p of a is equal to 0, then x minus a is a factor. And this relates to the remainder theorem because, as you might remember, p of a gives you the remainder, okay? And if the remainder is 0, then x minus a is a factor. So here we're asked to determine whether each of the following are factors of this polynomial, and here we're given x minus 2 as a factor. So what you want to do, right, according to this theorem, you just want to sub in p of 2, okay? Just like remainder theorem. And then you just want to sub it in, so 2 cubed plus 2 squared minus 3, 2 minus 6, 8 plus 4 minus 6 minus 6. And then if you added all of these together, you should get 0. And so because the factor theorem states that if p of a is equal to 0, then x minus a is a factor. So therefore, x minus 2 is a factor. Okay? All right, so let's go through one more question. So here you want to sub in p of minus 1. Because remember, the factor theorem uses x minus a. But here we have a plus. So we're going to be using minus 1. And then you just want to sub in minus 1 into this polynomial. So that's 1 cubed plus minus 1 squared minus 3 plus 1 minus 6. This is equal to minus 1 plus 1 plus 3 minus 6. Then finally, you should get minus 3. And so because this is not 0, right, x plus 1 is not a factor. Okay. All right, so I just wanted to go through one more question because I thought this is a really good question. So consider this polynomial, x cubed minus x squared plus 2x plus k. For what value of k will p of x divided by x minus 1 have a remainder of 5? Now, just to recap, right, the remainder theorem states that when a polynomial is divided by x minus a, the remainder is p of a, which is like what's happening right here. Okay, so what I can do, right, is I can write p of 1 because that is what the polynomial is being divided by, okay? And this has a remainder of 5 because they tell me that. All right. Now, what I can also do is p of 1. I can sub 1 into this polynomial because that's the same as p of 1. So 1 cubed plus 2, sorry, not plus 2, minus 1 squared plus 2 1 plus k. So this is equal to 2 plus k. All right. And since both of these are the remainder, right? 2 plus k is equal to 5. And so k is equal to 3. All right, that's it for factor theorem and remainder theorem.